To configure a radial adjust device for open-loop stepper drive control, first, set up the Axis object on the Configuration, Device, Controller page. The Drive tab of the Axis Setup control enables configuration of the stepper drive for use as a tool radial adjust. Settings specific to the stepper drive operation are available for setting I/O, the motor type, mounting orientation, micro-stepping, as well as the encoder resolution for endpoint correction. The Definition tab is used to configure the axis to be rotational and set up the counts per degree, derived from the stepper drive's microsteps and degrees per full step. The Home tab defines the homing setup when using the Home Axis script. The Home offset defines the position relative to the detected homing edge to set the home definition. The home definition is the value to assign at the home offset. In this example, the offset of -238 counts aligns the radial adjust axis vertically when moved to the 0 position. The Motion tab defines speeds and motion profiles. The Limits tab defines the forward and backwards limits, as well as a buffer for each direction that prevents users from triggering limit errors. ID sensor setup is done on the Configuration, Device, Sensor page. ID sensors have two configuration types: pass-through, which uses raw inputs from an I/O device, or a sensor configuration that uses the state of sensor devices as inputs. The sensor can configure the reporting value of the first input as least or most significant bit. The ID sensor device reports the binary combination of the configured inputs as a string value. The intent is to allow for functionality similar to other identifying devices like barcode scanners and RFID readers. Tool radial adjustment is added on the Machine Configuration Tool subpage. Each tool utilizing this feature is configured and calibrated separately. To add the radial adjustment features to a tool, enable it within the Radial Adjust tab. Access requires a license that contains the feature. The adjustment axis can be selected from controller axes that have been configured as a rotational axis. Pre- and post-adjust triggers provide additional functionality for safe operation, such as raising the robot's Z-axis to clear obstructions before moving. Tool radial adjustment is multi-purpose and can be used for tool tilt or axial rotation. In this example, the radial adjust feature is being utilized as a tool tilt. The calibration process can be adjusted to suit the needs of the system. Step defines the angle to divide the available range, altering the number of points for the calibration. The range slider changes the available range within the limits of the axis. The offset slider moves the points along the range. Typically, it is centered on 0. Two restrictions exist for starting the radial calibration. 1. The calibration must have at least 3 points. 2. One of the points must be 0. The calibration process requires a repeatable point. Here, a probe tip mounted on the calibration plate is used. While teaching positions, the endpoint of the radial adjust must be at the intended position and may require correction. The Fix Phi button moves the axis back to the intended angle. When calibrated, the tool will be able to utilize dynamic offsets to any angle. Unlike theta, radial adjust calibration does not include a global calibration. Each instance of the radial adjust axis must be calibrated independently. The radial adjustment feature can be controlled in a variety of ways. Scripts can be assigned to pendant buttons, placed into manual triggers, or direct control can be carried out through the Quick Action header menu. The Tool Changer feature is accessed from the Machine Configuration Tool Changer subpage. Access requires a license that includes the feature. Tools assigned to the robot can be added to the Tool Changers list of identifiable tools by selecting them in the drop-down. Adding an ID sensor to the configuration allows for automatic recognition of installed tools. Once added, tools are assigned an identifier, which is compared to the device's readings and controls the installed tools. Identifiers do not need to be unique and are not restricted to numbers. Identifiers should be configured according to the ID sensor's possible values. Adding the tool lock in the configuration enables automatic tool changing, allowing OEM users to add tool rests, which are configurable drop-off and pick-up points on the machine that hold the tools when not in use. The retraction properties define the offset distances the robot will use for clearance when picking up and dropping off tools. The Y retraction property controls the distance along the Y-axis that the robot will use when approaching pickup and retracting after drop-off. The Z retraction property controls the approach distance above the drop location used when dropping off a tool. The safe Y plane is a point along the robot's Y-axis. This absolute point on the Y-axis is safe to move along with any of the tools installed. When changing tools, the robot moves to the X-coordinate from the tool rest's drop location and the safe Y plane before moving into position. The pre-drop trigger executes before any operation that removes a tool. The post-pickup trigger executes after any operation that installs a tool. The preload trigger executes before any manual load or unload operation. Typically, automated tool changing requires the use of a radial adjust axis and can be configured in the same manner as on tools. Tool rests can be selected and configured in the Tool Rests pane. Each rest can select a designated tool from the list of identifiable tools. The tool sensor queries whether or not the tool rest currently holds a tool and adds a status indicator when configured. The rest actuator is an optional device that moves the rest into position for pickup and drop-off. When configured, a button is added that allows for manual operation. The drop location defines the point at which the tool changer will release or grab the tool during operations. All available axes can be set, including theta and the tilt axis. The tool changer's various triggers are required to ensure safety and proper operation of tools. The before tool change trigger ensures all outputs that are routed through the chuck are off. The after tool change trigger handles purging the tools and any other functions to ready the tool. The before operator load trigger moves the robot to a ready position and moves the tool changer's radial adjust axis to the position where the ID sensor can effectively read. To facilitate solvent timers for tools, individual timer triggers are created, each containing a drop tool script with a corresponding tool selected. If that tool is not currently held, the script exits without action. Manual operations for the tool changer are in the Quick Action header menu. When no tool is installed, the Load from Operator button is displayed. Pressing the button will execute the preload trigger, the pre-drop trigger, and then prompt the user to load the desired tool. Load the tool by hand. When the ID sensor detects any ID being read, the lock will engage. The post-pickup trigger will then execute. With a tool installed, the menu display changes, and a Drop to Operator button is shown. The Drop to Operator button will execute the preload trigger, the pre-drop trigger, and then await user interaction to drop the tool after a 3-second timeout. The Tool Changer menu also has a control for automatic tool retrieval. Select any tool and press the Pick Up Tool button. When a tool is picked up, the post-pickup trigger will execute. Picking up a tool when one is already held causes the pre-drop trigger to execute and the held tool to be dropped off. The desired tool is then picked up, and the post-pickup trigger executes. The installed tool can also be purged from this header menu by pressing the button on the left of the pane. Finally, the Drop Tool button will execute the pre-drop trigger and then drop off the held tool to the tool rest. When creating programs, some operations while using the tool changer require special consideration. For instance, some installed tools may impede a Z-mounted camera performing fiducial offsets, as the length of tools can cause crashes on purge cups, board stops, or other obstructions. Before fiducial checks or inspections, it is advised to drop off any currently held tool. By using the Change Tool function and leaving the Tool checkbox unchecked, any held tool will be dropped off before continuing the program. After steps involving the camera are completed, adding a Change Tool step will ready the tool for use in the program. Here a dispense is being configured with a spray valve. The tool tilt will be utilized to approach the dispense target from an angle. Note that by default, the fifth axis is not enabled. This is the radial adjust axis, and is labeled with the Greek letter phi for shorthand. When using the Teach tool, the theta and phi axes are not enabled, because the Teach tool is only mounted to the x, y, and z axes. The coordinates are edited to give a specific theta and phi position for the anchor step. The approach vector is automatically updated and places the phi in the sequence before the z move. It is not advised to place the phi with other axes, as it cannot participate in coordinated motion. A warning is displayed that indicates that phi will not perform coordinated motion. If phi is left in a lane with another axis, phi will always move first. Due to the open loop control of the tool tilt, it is critical to reinforce the axis position often. Adding a move within the dispense step that sets only the phi position will improve accuracy. The endpoint for the phi axis can be altered at any time, and the tool placement will shift the robot accordingly. Here, the angle is changed to 0, and the step runs to demonstrate the change. Here, the endpoint for both theta and phi are altered, and the step played to demonstrate the differing approach to the same point. If a change tool step is missing, or does not select the tool required for a given dispense path, the program will error before moving to the dispense anchor, notifying that the tool is disabled.